Welcome to our final project presentation.
My name is Roman Yamalidzinov.
I'm Nick Johnson.
My name is Vin Nguyen.
Johnny, say your name.
Okay, I'm Johnny.
And I'm Kevin.
So our final project was basically to build, code, and assemble a functioning RC car that drives via wireless control from Raspberry Pi. The RC car has extra accessories such as headlights, taillights, brake lights, a horn, hit detection, camera feed, and a convertible rooftop. All of these functions, including the driving part, are meant to be controlled wirelessly via Raspberry Pi. Here's what the remote control vehicle looks like. You can see it's a Nissan 350Z. We got it from a Goodwill store for about $8. And we gutted it and we put all of our parts on the inside. So I'm Nick. I made the car move forward and backwards. I made the car steer left and right. You could type keystrokes on the Raspberry Pi to make it go vroom vroom. For example, you could press G for go, B for backwards, L and R to steer left and right. And if you want to stop it, you just press S.
Okay, I made a whisker for hit detection and a push button that acts as a back hit detection. When hit from either direction, the car has a speaker that outputs a loud beep or can be used simply as a horn. The whisker is made from paperclip, and when detected, both Parallax Pi and the horn will always display messages.
I'm Kevin. I was in charge of the lights. We have all sorts of lights on the car. We have front lights, left turn signals, right turn signals, and brake lights, and we control them via the Parallax and the Pi. The Pi can override the Parallax to do things.
Alright. So camera feed is my part, so I make the camera to recording the vehicle and the rear camera turn on at the vehicle to reverse. That part we cannot make it possible. Happens in the Raspberry Pi we use cannot handle two cameras at the same time. So for the front camera, when the sensor detect the collisions from Johnny part, the front camera will turn on and record the collision, which have the option to store it inside the client, which is Raspberry Pi, or can be uploaded to server via the API to Dropbox. For the rear camera, which we cannot make it work, but the features will be when we're reversing, when the Nick's turn the reverse mode on, it will turn on the rear camera screen on, so it's easier for him to reverse as safety.
From our part, I learned how to use an H-bridge to make a motor go forward and backward so that the moonroof could open and close. And so when you click U, then the moonroof opens, and when you click D, the moonroof closes. And that was my part.
Right here you can see images of the circuits that we use for motor control. On the left you can see the Raspberry Pi and the motor driver. You could also see the GPIO pins being connected through the motor control, and also the brown and blue wires you see on the bottom are for the front, and then the red and orange wires on the top control the steering. For each of the keystrokes you can press, it activates those motors, allowing the vehicle to move.
Ready.
Reverse.
It stopped.
Okay.
Reverse it. Reverse it while...
Pictures of my front whisker and my push button for the back, and the code.
Here's the code.
So mainly, yeah.
Okay, so this is a diagram of the lights, how it is wired up. So the first part is we have basic light control on the Parallax, which the car movements dictate. And then we have a mode where the user is able to control the lights via the Pi. We didn't get this working fully in the final version, but we also made the Pi into a server. And you can use a separate client to get the Pi to control the Parallax. And the front headlights are via a light detecting resistor. For the headlights, this is the diagram we used. And this is the code that I have. And
This is a demo of all the lights in the final project. Right now, by default, it stopped, so the right lights are on. If I turn left, the turn signals will blink. If I turn right, the other turn signals will blink, and so will the ones in the back. And there's a mode called Pi Control On, which will allow the Pi to take over the parallax, and then I can do stuff like hazards, which make the lights blink. And then I can do stuff like on, which will turn all the lights that I manually control on. And the front lights work with the darkness sensor.
So for my camera control, I use is a Raspberry Pi camera modular for set up as the front camera. It's gonna be like use a Python control through the microcontroller, which is the parallax. So when heat detection received, the camera will turn on and recording what the collision happened. So this is the first setup, like individual setup before like put into the RC card. This is the code I have for capture and upload, and this is the.
So, for my part, the first part that I did was learn how to use an external power source to control the motor, and so I just used an NPN transistor to use the positive output of the GPIO pins to make the motor spin using the external power source. And then for the next part, I learned how to use an H-bridge to make the motor spin in both directions so it could open and close the moonroof. And then in the end, I decided to just use an H-bridge IC chip because it took up less space and it was easier to program on the Raspberry Pi. And this is the code for my part. And these are some pictures of how it looks. And it was difficult to attach the motor to the car and to make this whole mechanism work. And that was one of the hardest parts.